Welcome to this short video that hopefully by the end you have a better understanding of why and where the solutions are on a quadratic equation graph. Let's take a look at a couple examples here. This parabola is first. So all quadratic equations will have a parabola as a shape, and a parabola is symmetrical. So the line of symmetry runs straight down the middle here, and the line of symmetry will be whatever the x value is of the vertex. And the vertex is either the highest or the lowest point of your parabola. In this case, this parabola opens up. That means our a term in the quadratic equation will be positive. And when a parabola opens up, we will have a low point, a minimum. So the solutions for a quadratic equation, we will either have 0, 1, or 2, and I'll show you examples of each. But this one here has two solutions, and you can see them represented by the blue dots at -3, and the other solution is 1. Now if we were writing those as ordered pairs, we would use parentheses. That's the only time we use parentheses is when we're writing ordered pairs or coordinate points. If we're listing solutions, we do not use parentheses, we simply list them. So if we were listing the solutions for this parabola, we would write -3, 1. If we were writing them as ordered pairs, it would be -3, 0 inside of parentheses, and then we would have 1, 0 inside of parentheses. So this parabola opens up. We know that the a term would be positive and that this has a vertex that is a minimum. That is the lowest point of the graph. Because this parabola passes the x-axis, these are the two solutions. This is where y equals 0, and that is why we set the equation equal to 0 to find the points at which the graph crosses the x-axis. So again, this example here has two solutions. If we scroll down, we see a little bit different example. It still opens up, so the a term would be positive in the equation. But as you can see, this graph does not cross the x-axis. It lands on the x-axis, and that is why there's only one solution. The y value of the solution would still be 0. The solution is actually +1. The vertex lands on the x-axis. If we were writing this as an ordered pair, it would be inside of parentheses 1, 0. If we were just listing the solution, it would be +1 with no parentheses. So this is one real solution. Finally, we have an example here of a parabola that opens up, has a minimum point as a vertex, but it does not cross the x-axis at all. It doesn't land on it and it doesn't cross it. So when you have a quadratic equation that does not cross the x-axis, there are no real number solutions. So here we have an example of a parabola that opens down. That means that the a term, the a coefficient in the quadratic equation will be negative because it opens down. That means our quadratic equation will have a maximum point. That means the highest point on a graph. If you think of this as like bouncing a ball, you would start and then bounce the ball. It reaches the maximum height and then it drops back down to the ground. So the maximum part would be the vertex here with a parabola that opens down. And this parabola, again, does not cross the x-axis. Therefore, we do not have any real solutions. Looking at another example of a parabola that opens down, the vertex, which is a maximum again in this case, does not cross the x-axis. The vertex is on the x-axis. That means we have one solution, and this solution here would be -1. If we were writing that as an ordered pair, it would be -1, 0. And then again, a quadratic equation, which is a parabola that has two solutions, -1 and 3. And this parabola opens down and has a maximum point. And again, the vertex is the line of symmetry, which falls directly between the two solutions. So I hope you understand these few things, that a quadratic equation can have 0, 1, or 2 solutions, depending if it crosses the x-axis. And those solutions will always have a 0 y value, and that's why we set the equation equal to 0. And you will also know if your parabola opens up or down depending on the a coefficient of your quadratic equation. I hope that helps, and good luck.